right, let's go ahead and look at the 7th grade text, chapter 5. We're going to be looking at equations. The first thing that you need to know is that an equation has an equal sign. It also has more than one part. An equal sign is going to allow you to have a left side on the left side of your equal sign and a right side on the right side of your equal sign. One thing that we can realize is that sometimes the sides of your equations, or whatever side is on one of the sides of your equal sign, can be just a number, or it could be a little bit of arithmetic that needs to be solved. We can all probably agree that 2 plus 3 does in fact equal 5. This is an equation because we can say that the part on the left of the equal sign really does equal the part on the right. So for instance, if we were going to draw this instead as a pan scale, or like a justice scale, where we could measure weight, we could draw it like this. All right, so we're looking at this scale. We're going to draw 2 plus 3 over here on the left, and we are going to draw the right side of our equation, or 5, over here on the right. So I'm going to go ahead and do that, starting with 5. 1, 2, 3, 4, 5. I'm going to draw 5 tally marks, whatever that is. It could be apples, it could be grams, it could be seashells, paper clips, whatever it is. We have 5 of them on one side, and we're talking about increments that are exactly the same weight, or mean the same thing. So I'm going to come over to the left side and start building that. It says that we have 2. All right, so I have 2 in there. And then it says that I'm adding 3 more. 1, 2, 3. Indeed, there are 5 on both sides. So if we went back to our original equation with numerals, we could actually solve the left side to see what it represented. And I know that 2 plus 3 equals 5. So therefore, both sides of my equation are actually equaling the same thing. The hard part here is that we're starting to see this instead of solving one side to equal the opposite side. We're starting to see now that an equation is really a balancing act. So let's take a peek at some more examples here. So there are all sorts of simple equations that could be done. Let's go over a few simple ones really quickly so that we can see all of them. So we're going to start with an addition problem. We're going to do x plus 6 equals 13. Now remember, the goal here is to make both sides equal. So whatever x plus 6 actually is, whatever that variable of x is, whatever number that's representing, plus 6 in this instance is going to equal the same exact thing as what's on the opposite side of my equation. And in this case, it happens to just be a numeral of 13. So at this point, what you're really doing is thinking, what can I add to 6 to make 13? And why am I doing that? Because I'm comparing the left side of my equation, my x plus 6, to 13, which I know is going to be equal to the exact same amount. Now, that kind of thinking is crucial for solving equations, but what's interesting is we have to make sure that we are able to do the work as well. So for instance, if we were looking at our pan scale again, we'll keep that our left side, and 13 will be our right side. If we had 13 over here. All right, so there's 13 marks. We know for a fact over on the left side that we have 6. And we have a mystery number of additional pieces on our scale. Now, in order to figure out what x is, we want to be able to get x alone on the scale. And the only way to do that is to get rid of that extra 6 that is over on the left side. So right now we're adding 6 to that side of the pan. We need to do the opposite to get that 6 to go away. So instead of adding them, we're going to take them away. So the operation here is going to be subtracting. So I'm going to go ahead and I'm going to take 6 away. Now remember, the point here is to make sure that both sides of our equation are literally equaling the same thing. So if I'm taking 6 away from my left side, then in order to keep my scale balanced, I have to take away 6 from the right side as well. And I went ahead and I did that. And now we can see the only thing that would be left over down on the bottom would be x on the left, whatever that is, and 7 on the right, which is what is left over from 13 when I take 6 away. Now I'm going to show you this in actual, the procedural form here. So remember, in order to balance these, we said that we were going to try to get x alone. So in order to get x alone, we're going to take 6 away from that left side. All right, so if we have 6 and we take 6 away, we're left with 0. So in essence, we can put a line through that and say that they cancel. They're not there anymore. We don't have to worry about them. But remember, in order to solve an equation, we need to balance both sides. So again, if we're taking 6 away from the left, in order to keep our scale balanced, we have to take away 6 from the right. So we're looking at 13 minus 6. I can actually solve this without cancellation. So 13 minus 6 is 7. And if we went back and looked at the left side of our equation, we can see that the only thing that's left on that side is x. If we drop that down, and we keep our equal sign, our new equation, solved equation, is x equals 7. So let's make sure that that's actually true. I'm going to take that 7 and plug it in for x and rewrite it at the top. 7. And the rest of my equation was plus 6 equals 13. Is that true? Is 7 plus 6 actually 13? Yep. They are now equal. That's an addition problem. Let's look at a subtraction problem, and then that'll be it for now. All right, let's look at x minus 5. Equals 11. So if we're looking at our scale down here in the bottom, we know that there are 11 markers on one side, and however many are on our left side are actually going to have 5 of them being negative. So I'm actually going to draw 5 of them in red. So the reason why they're in red is to represent that they are negative, or they would be pushing us to the left side of the zero on a number line. So we're taking away at that point. Let's go ahead and see how to solve it. Remember, our goal is to get x alone on the left side, so that the only thing that is left is the part on the right side of our equation that tells us how much x is, because equations are all about balancing the scale, keeping things equal on both sides. So, in order to do so, the only thing that's on the same side as x is minus 5. So, instead of taking away 5, I'm actually going to add 5 here, because I want them gone. So now I'm going to come back and I'm going to, instead of having these 5 be red, I'm going to turn them into an actual color. And because they were negative, now I have positives, they end up canceling out. If I owed you $5 and I gave you $5, my debt would be paid. All right, so that ends up canceling out. Now remember, to keep it balanced, I've put an additional 5 on the left, which means I'm going to put an additional 5 on the right. This I can actually solve, or I could count, and I know that it's going to be 16. And what equals 16? X equals 16, because x is the only thing left on that side, which means that I can go back and I could try to solve this problem the way that we just figured out that, because we just figured out that x equals 16. So I'm going to take 16 and I'm going to plug it in for x. My original problem was x minus 5 equals 11. Instead of x, I am going to substitute 16. Is it indeed true that 16 minus 5 equals 11? 16 minus 5 does equal 11. Both sides of my equation are the same. We're good to go.